So what we're going to do is now we're going to talk about how can we solve differential equations, an ODE, a first order ODE. And we're going to talk about many different methods. We're going to talk about one of the very first methods. It just depends on what kind of equations you happen to have as to which method you use. In this case, we're going to talk about what we call separable equations. Separable equations is where you have a first order differential equation, dy dx, is equal to some function of x times some function of y. And notice the function of x, g of x is just of x, and h of y is just of y. So we can actually separate these up. And to solve these, we're going to divide through by the h of y, brings it over to the other side of the equation. We're going to multiply through by the dx, bring it up to the other side of the equation. And we now have two different sides. The left-hand side only involves y. The right-hand side only involves x, which means I can now just take the integral of both sides. And so that's what we're going to do. We're going to take the integral of both sides to solve this. So let's take an example. We're going to solve dy dx plus 2x squared, plus 2xy squared equals 0. So we're going to solve this differential equation. The first thing I do need to do is put it into normal form. So I'm going to get the dy dx by itself. So subtract off the minus 2x and the y squared. Minus 2x is a function of just x. Y squared is a function of just y, and we can now separate those. So we're going to divide through by y squared. And we're going to multiply through by dx so that we get the dx on the right-hand side, and we leave the dy by itself on the left-hand side with the 1 over y squared. And now what you do is just take the integral of both sides. So we've got the integral of y to the minus 2 dy equals the integral of minus 2x dx. The integral of y to the minus 2 is minus y to the minus 1. The integral of minus 2x is minus x squared. And then, because we're now done taking integrals, we will have a plus c. You only need the plus c on one side of the equation, so that works out. Now, the only other thing we need to do is get y by itself. Solve for y, in other words. So I'm going to multiply through by negative 1. So y to the negative 1 is equal to x squared. I could write minus c, but c is just an arbitrary constant, and I can absorb that negative sign into the c. So I can just keep it as plus c. Makes my life a little bit easier. Now to get y, this is basically 1 over y. So we'll multiply through by y, divide through by x squared plus c. So we get y equals 1 over x squared plus c. And there's your solution. Unfortunately, it's not necessarily the only solution to this. We made an assumption up here when we divided through by y squared. And we made a very important assumption here when we did this. And the assumption was that we assumed that y was not 0. Because otherwise, we couldn't divide through by y squared if we didn't assume that y was not 0. So that means that we cannot get y equal to 0 out of this equation. Y equals 1 over x squared plus c will never give you y equal to 0 as an answer. But y equals 0 could be a solution to the differential equation. In fact, if I look at this differential equation, if y is 0, we're going to get the derivative of 0 is 0, and y is 0. You're going to get 0 equals 0. So we actually do, in fact, get a solution of y equals 0, but you're never going to get it out of this solution here. There's no way to get y equal to 0 out of this solution. So that tells me that y equals 0 is a solution. We can't get it from that, so we call it a singular solution. And we know that, and we can find that singular solution from what we assumed y was not equal to. We assumed y could not equal 0 here, so that means y equals 0 is my singular solution. Let's try one more. Dy dx is equal to xy plus 2y minus x minus 2 all over xy minus 3y plus x minus 3. This does not look the least bit separable, but let's see if we can't do something with it. First thing I'm going to do is I'm going to go ahead and, I don't like fractions, so first thing I'm going to do is multiply both sides by the denominator. So that's all being multiplied by dy. And then we have xy plus 2y minus x minus 2 all times dx. And now let's see what we can do with this. Well, again, this doesn't look like a whole lot, but I do notice that there's 4 terms here. I notice that the y is common in the first 2. I could, in fact, factor that y out of the first 2. And if I factor that y out of the first 2, I'm left with x minus 3. And I notice that the second one, if I were to factor a 1 out, I would also have x minus 3. So it looks like I can factor this by grouping. And it looks like when I factor this by grouping, I in fact get y plus 1 times x minus 3, which is actually separable. So let's see if we can do it with the other side. Well, I notice I have xy plus 2y. I can factor a y out of there. So when I factor that y out, I'm left with x plus 2. I notice minus x minus 2, I can factor out a negative 1, and I'm left with x plus 2. So it looks like, again, I in fact can factor this by grouping. I'm going to get y minus 1 and x plus 2 dx. And so now what I've done is I actually do have a y term times an x term and a y term times an x term, and get my y terms on the same side. So divide through by y minus 1, divide through by x minus 3. And now I actually was able to separate it. So now I can, in fact, find the integral of both sides and find out what I get. Now, this, you do know how to find these integrals. I'm not going to show you how to do this. You actually can use your technology. So you can use your TI-80, your Inspire calculator, your TI-89. You can even use Wolfram Alpha. I don't really suggest Wolfram Alpha all that often, but given the semester, we can use that one also if you're online. So I don't like Wolfram Alpha. I try to avoid it, but I'm going to go ahead and do it really fast just to show you how I can get Wolfram Alpha to do this for me. So I'll go into Wolfram Alpha, and I would like to do the integral of, let's see, we had y plus 1 divided by y minus 1 and that integral, and when I go to do that integral, Wolfram Alpha tells me oh, sorry, I typed something wrong. There we go. Okay. So Wolfram Alpha tells me that it's y plus 2 log of y minus 1. Actually, that's y plus 2 natural log of y minus 1. Wolfram Alpha uses log instead of ln. So we now can write that in there. And again, you can use technology for this. This is actually just using partial fraction decomposition to find that. So that's how you would find that integral. And so we get y plus 2 natural log. Remember, when you take the natural log, you have absolute value of y minus 1. Do the exact same thing with the other side. Do the same thing with this one, and you would get x plus 5 natural log of the absolute value of x minus 3. Since I've finished taking the integral, I would now have a plus c on this side. You can then, if you want to, solve this for y, but I wouldn't want to. In fact, I don't think you actually can solve this for y because you've got y inside of a natural log and y outside of it. So you're pretty much done. This is going to be an implicit function instead of an explicit function, and that's okay. We also can look to see if we had a singular solution. So we did, in fact, divide by some y term here. We actually divided by y minus 1. When we did that, we had to assume that y was not 1. So my singular solution is y equals 1. And And that's all there is to doing these. And then you can also, if you happen to have an initial condition, you can solve for your C by plugging in at this point and solve for C. So if I told you that y of 1 was, actually, let's do y of 4 was 7, you could actually go and plug that in and find out what C is. We won't bother doing that right now, but that's what you can do.